Okay, I hope I'm audible to all the students who are attending this lecture. We continue with our lectures on vector algebra. And in the last lecture of vector algebra, we had discussed about what is a vector. Okay, any quantity which has both magnitude as well as direction is called a vector. Okay, we had talked about the initial point of a vector, the terminal point of a vector, the magnitude or the length of a vector. Okay, we had also talked about position vector in the 3D space, the concept of direction angles, direction cosines, and the direction ratios. Okay, now in this lecture we intend to look at the type of vectors. So our heading now is type of vectors. Okay, so first we have the zero vector. So let us see what is a zero vector. So a vector whose initial and terminal points coincide. A vector whose initial and terminal points coincide is called a zero or a null vector, and is denoted by 0 with a slash with a bar on the top. Okay, so any vector whose initial and terminal points are the same is called a zero or a null vector and is denoted by 0 with the bar on the top. Okay, so zero vector cannot be assigned a definite direction. Zero vector cannot be assigned a definite direction as it has zero magnitude. Okay, so you cannot assign any direction to the zero vector because clearly it has zero magnitude. The initial and the terminal points are the same. Since they are the same, the vector has no magnitude. Since the vector has no magnitude, you cannot assign any particular direction to that vector. Or other way of saying it is as follows. We can say that zero vector may be regarded as having any direction. Zero vector may be regarded as having any direction. This is another way of saying it. So how do we represent a zero vector? So I can say vectors. If I write vectors AA with a bar on the top, or if I write vector BB with a bar on the top, they represent zero vectors. So vectors AA with a bar on the top, vector BB with a bar on the top represent zero vectors. So I hope all students have understood the definition of a zero vector. That vector whose initial and terminal points are the same is called a zero or a null vector. It is denoted by 0 with a bar on the top, 0 bar. Okay, you cannot assign a definite direction to a zero vector. Why? Because it has zero magnitude. Since it has zero magnitude, you cannot assign one particular direction. Another way of saying it, zero vector may be regarded as having any direction. And the vectors AA bar and BB bar represent zero vector. This is one particular example. Then guys, let's look at the second type of vectors called unit vectors. So what are unit vectors? So a vector whose magnitude is unity, or I can say equal to 1, is called a unit vector. So a vector with magnitude equal to 1. That means, another way of saying it, if the length of the vector is 1, that vector is called a unit vector. So how do we denote it, guys? So I can write it. The unit vector in the direction of a given vector A, the unit vector in the direction of a given vector A bar is denoted by, so we denote a unit vector by a cap on the top. If you draw a cap on the top, it means it's a unit vector. It has magnitude equal to 1. So I'm quickly revising it. Unit vector is that vector whose magnitude or length is exactly equal to 1. How do you denote a unit vector? So suppose I talk about a given vector A bar. So the unit vector in the direction of this given vector A bar is denoted by A with a cap on the top. Okay, moving forward to the third type of vector, denoted as co-initial vectors. Okay, co-initial vectors. So guys, let's talk about co-initial vectors. Two or more vectors having the same initial point, the same initial point are called co-initial vectors. Two or more vectors having the same initial point are called co-initial vectors. Very simple. If there are two or more vectors which are having the same initial point, that means if they are starting from the same point, they are called co-initial vectors. Okay, then let's talk about collinear vectors. What do we mean by collinear vectors? Okay, so let's talk about collinear vectors. Two or more vectors are said to be collinear. Two or more vectors are said to be collinear if they are parallel to the same line. If they are parallel to the same line, irrespective of their magnitudes and directions. Irrespective of their magnitudes and directions. So two or more vectors are said to be collinear if these vectors are parallel to one common line, irrespective of their magnitudes and directions. That means in collinear vectors, it doesn't matter what are the magnitudes of the vectors or in which direction they are going. All what matters is that collinear vectors are parallel to the same line. Other way of saying it, basically they are parallel to each other. Okay, so if two or more vectors are parallel to the same line, irrespective of what magnitude or direction they have, they are said to be collinear vectors. Then guys, let's talk about what is meant by equal vectors, or when are two vectors said to be equal. when are two vectors said to be equal? So I can write two vectors A bar and B bar are said to be equal. Two vectors A bar and B bar are said to be equal if they have the same magnitude, if they have the same magnitude and direction, if they have the same magnitude and direction regardless of the positions of their initial points, regardless of the positions of their initial points. Okay, so we say that two vectors A bar and B bar are said to be equal if both these vectors have the same magnitude, same length, and same direction also. If two vectors have the same magnitude as well as the same direction, they are said to be exactly equal. Now guys, that does not matter what is the position of their initial point. When we talk about two vectors being equal, we do not look at where the initial points are starting from. The initial point of both these vectors might be different. What should be same? Magnitude should be same, direction should be same, regardless of where the initial points of these vectors lie. Okay, moving on to the sixth type, negative of a vector. Negative of a vector. So a vector whose magnitude is the same, a vector whose magnitude is the same as that of a given vector, a vector whose magnitude is the same as that of a given vector, but the direction is opposite. But the direction is opposite to that of it is called the negative of a vector. Is called the negative of a vector. Basically, guys, if you have a vector which has the same magnitude as the initial vector, but the direction is exactly the opposite of the initial vector, then that is called the negative of a vector. For example, vector BA is the negative. Vector BA is the negative of the vector AB, and written as, so I can write it as, it can be written as vector BA is minus of vector AB. Now guys, both these vectors BA and AB have the same magnitude. What is different? BA is going in the opposite direction as compared to the vector AB. For example, if vector AB is going in the northwest direction, vector BA will go in the southeast direction, exactly opposite. So quickly revising, co-initial vectors are those vectors which start from the same initial point. Collinear vectors are two vectors are said to be collinear if they are parallel to the same line irrespective of what is their magnitude or direction. Two vectors are said to be equal if they have the same magnitude and same direction regardless of their initial point. A vector with the same magnitude as the initial vector but opposite direction of that vector is called the negative of a vector. For example, BA is the negative of the vector AB. Both these vectors have the same magnitude but opposite direction. Okay, so I hope all students have understood this. So let's do some practice questions now of denoting vectors. Let's look at some practice questions. So so first question, represent graphically a displacement of 40 kilometers 30 degrees west of south. Okay, so we represent this by using a vector. Okay, this is the origin, this is my west direction, this is my east direction, this is my north direction, this is my south direction. So displacement of 40 kilometers means from the origin 40 kilometers 30 degrees should be the angle made with the axis, and west of south, that means southwest. So I can draw a vector in red. You can see this is my vector OP. What is the length of this vector? The length of this vector is 40 kilometers, and it is making an angle with the axis of how much? 30 degrees. So you can see I've drawn a vector OP. It is going in the southwest direction. 30 degrees is the angle made with the y-axis, and 40 kilometers is the displacement of this vector. So I hope all students have understood this. Okay. Moving forward to the next type of a question. Now we have some simple questions where you are asked to identify whether it's a vector or a scalar. So classify the following measures. Classify the following measures as scalars and vectors. So students should be able to understand what is the difference between a scalar and a vector, which we had discussed in the previous lecture. A scalar is a quantity which only has magnitude. A vector is a quantity which has both magnitude and direction. So for example, 5 seconds. Is this a scalar or is this a vector? You can clearly see it's a scalar. It's a scalar and the unit is in time. It's a scalar of time. Similarly, second example I take 1000 centimeter cube. Again, guys, there is no direction. It is just magnitude. So scalar. Cube means it's volume. It's a scalar of volume. Okay. Then third, we have 10 Newton. Okay. So this is something we do in physics. 10 Newton. So again, you can see when we talk about Newton, it is now a vector. It is a vector of force. In physics, when you do force measured in newtons, so 10 Newton is a vector of force. Similarly, I can take more examples. So let's take more examples. So let's take the fourth example. 30 kilometers per hour. Now you can see this is speed, but there is no direction here. So scalar of speed. It's a scalar of speed. Then we have 10 grams per centimeter cube. Okay, this is again a scalar because there is no direction here. 10 grams per centimeter cube, it's a scalar of density, grams per centimeter cube. Okay, and the last we have 20 meters per second towards north. Now you can clearly see that this quantity, this is speed. It has both magnitude as well as direction, north. So it's a vector of velocity. It's a vector of velocity. Okay, so you can clearly see now. I hope students have understood how to identify. I hope students have understood how to identify which quantity is a vector and which quantity is a scalar. Okay, so any quantity which only has magnitude attached to it is a scalar, but any quantity which has both magnitude as well as direction attached to it is a vector. Okay, let's look at the third question. Let's look at the third question. So guys, we are drawing a figure. So consider the figure. So it's a figure based question. So you can clearly see I'm drawing vector. This is my vector A. Okay. This is my vector B. This is my vector C in this direction. And this is my vector D in the other direction. Okay. So these are all vectors, vector A, vector B, vector C, and vector D. Now the question asks you, from the diagram, from the above figure, we need to answer the following. Which of the vectors are first thing they ask, collinear? Which of the vectors are collinear? Which of the vectors are equal? Which of the vectors are co-initial? So guys, let's go back to the definition. When are vectors said to be collinear? Vectors are said to be collinear if they are parallel to each other. That means they are parallel to the same line. So you can see vectors A is parallel to vector C. Vector A is also parallel to vector D. So I can say vectors A, C, and D are collinear. Vector A is parallel to vector C. Okay. Vector A is like also parallel to vector D. And vectors C and D are lying on the same line. So all three are collinear. If I talk about equal vectors, you can see only vectors A and C are equal. Why? Because both A and C have the same magnitude. They have the same direction also. So they are equal. And co-initial vectors, there are three co-initial vectors B, C, and D. Because you can see all these three vectors are starting from the same red point. You can see vector B is also starting from this red point and moving in this direction. Vector C is also starting from this red point and moving in this direction. Vector D is also starting from this point and moving in this direction. So all these three vectors have the same initial point, hence they are called co-initial vectors. So I hope all students have understood this. Okay. Similarly, we can do one more question, question 4. Okay. So again, we are given a figure. So consider the figure. consider the figure. Now this is given to us as follows. Vector A is in this direction. Okay. Vector B is in this direction. Vector C is in this direction. And vector D is in this direction. Now the question asks us identify from the above figure, identify the co-initial vectors, identify the co-initial vectors, identify equal vectors. Okay, identify equal vectors. And third thing they ask, identify collinear but not equal vectors. Collinear but not equal vectors. Okay, so guys, what are co-initial vectors? Those vectors which have the same initial point. So from the figure you can see vector A and vector D are co-initial vectors. Why? Because they have the same initial point, which you can see in red color. Vector A is also starting from this point and moving in this direction. Vector D is also starting from this point and moving in this direction. What are equal vectors, guys, in this case? Vectors which have the same magnitude and direction. So you can see vectors D and D. If you look at vector D and if you look at vector B, they have the same magnitude. Direction is also same. Vector D is also going south. Vector B is also going south. And which vectors are collinear but not equal? Now you can see vectors A and C are collinear. Why? Because they are parallel to each other. But why are they not equal? Because the directions are different. Vector A is going in the west direction. Vector A is going in the east direction. Let me correct myself. And vector C is going in the west direction. So A and C are not equal vectors because their directions are different. But yes, they are collinear because they are parallel to each other. So I hope that students have understood this and have no doubts in this. Okay, so guys, let's now move forward to a new concept. So before doing that, let's do a true and false type of a question. So let us do a question based on true and false. So we are writing some statements and let us check whether they are true and false, whether they are true or false. Basically, it's exercise 10.1 of NCRT. Okay, of vectors, and this is question 5. So vector A and minus A are collinear. Second statement is two collinear vectors are always equal in magnitude. Okay, two collinear vectors are always equal in magnitude. Third point is two vectors having the same magnitude two vectors having the same magnitude are collinear. And the last statement is two collinear vectors two collinear vectors having the same magnitude are equal. So now guys, let's read these statements again and let us check that out of these, which given statement is true and which given statement is false. Okay, so vector A and vector minus A are collinear. It's a true statement. Why? Because if you see, both these vectors will have the same magnitude but opposite direction. So they will lie on the same line. For example, if I draw a vector A, suppose vector A is in this direction. Suppose this is vector A. Then vector minus A will be, this will be the initial point, minus A will be in this direction. So you can clearly see that they are collinear because they lie on the same line. So it's a true statement. Second statement is two collinear vectors are always equal in magnitude. Not necessarily true. It's a false statement. It's a false statement because if you look at the definition of a collinear vector, nowhere we said that collinear vectors should have the same magnitude. If you all can recall the definition of collinear vectors, two vectors are said to be collinear if they are parallel to the same line irrespective of their magnitude or direction. That means we don't care about the magnitude. As long as they are parallel to each other or they are lying on the same line, they are collinear. So this statement is false. The third statement, two vectors having the same magnitude are collinear. Okay, so again, it's a false statement because having the same magnitude does not mean that they are parallel to each other. I repeat, two vectors having the same magnitude does not mean that they are parallel to each other. So they may not be collinear. So again, it's a false statement. And the last statement is two collinear vectors having the same magnitude are equal. Again, this is a false statement. Why? Because all of you know that two vectors are said to be equal if they have the same magnitude as well as the same direction. Now, nowhere in this statement we have talked about direction. All we have said is that two collinear vectors have the same magnitude are equal. No. Two vectors having the same magnitude are not equal. Two vectors having the same magnitude as well as direction are equal. So it is a false statement. So I hope all students are clear with this. Okay. Let's now move forward. Let's talk about the concept of addition and subtraction of vectors. So our heading now is addition of vectors. Okay, so let us see how do we add vectors. So guys, again consider this figure. Consider this figure, guys. Suppose there's a point A, suppose there's a point B, and suppose I have a point C. You can see there is one vector from point A to point B in this direction, one vector which is from point B to point C in this direction. Now there are two ways. I can go from point A to point B and then from point B to point C, or I can directly go from point A to point C. There are two ways of going from point A to point C. Either I directly go from point A to point C, or I go from point A to point B and then from point B to point C. So I can write, therefore, AC vector is the sum of AB vector plus BC vector. And this is called as triangle law of vector addition. This is called as triangle law of vector addition. I can either directly go from A to point C, or I can go from A to B and then from B to C. Okay, so guys, if I denote this by vector A, if I denote this by vector B, and if I denote this by vector C, then AC is nothing but vector C. So I can write vector C is nothing but the sum of vector A plus the sum of vector B. So vector C, which is AC bar, is equal to the sum of vector A, which is AB bar, plus the sum plus the vector B, which is BC bar. I hope students have understood this. And guys, now let me draw another figure for you. Let me draw another figure for you where you can clearly see I have point A, I have point B, I have point C. Okay, this is AB vector, which I denote by vector A. Okay, this is BC vector, which I denote by vector B. Okay, now guys, if this is vector B, what will minus of B be? Minus of B will be a vector in the opposite direction. From B, if I draw a vector with the same magnitude but in opposite direction, it's called minus B. All of you have just done the concept of negative of a vector. That vector which has the same magnitude as the initial vector but opposite direction. So negative of vector B is the vector in red, you can see. Now if this is vector A and this is vector minus B, if I join these 2 points, suppose I call this as point D. If I join points A and D, what do I get? The addition of this vector and this vector. That means A vector plus minus B vector, which makes it minus B vector. So you can clearly see now the difference between the vectors. So I can write from this figure AD vector is equal to AB vector plus BD vector. Again using the triangle law of vector addition. So AD vector, so what is AB vector, guys? AB vector is denoted by A, BD is denoted by minus B. So this is A vector minus B vector. This is nothing but my AD vector. So I hope all students have understood this particular concept. Okay. So now we can move forward. Okay. So we can now do the parallelogram law. Okay. That is also something new for all of you. So let's write the heading parallelogram law of vector addition. Parallelogram law of vector addition. So you can see now I am drawing a parallelogram using vectors now. So you can see this is origin O. Okay, this is vector OA, which I denote by vector A. Okay, this is another point AC is denoted by vector B. So if I join O with C, I get the vector A plus B, vector A plus vector B. Okay, and then I can draw a vector which is parallel to the vector B. So you can see this is another vector. You can see this vector is also B. And if I draw another vector, you can see this vector is also vector A. Okay. because you can see the directions are the same and they are parallel to each other. The magnitude is also the same because opposite sides of a parallelogram are equal. Okay. Similarly, you can look at, let me draw it more accurately. So I can draw it like this. This is vector B, this is vector A. Okay, so let's write the parallelogram law. So if we have two vectors, if we have two vectors A and B represented by the adjacent sides, we have two vectors A and B represented by adjacent sides of a parallelogram. Okay, in magnitude and direction. As you can see in the figure, guys, two vectors A and B represented by the adjacent sides of a parallelogram in the magnitude and direction, then their sum A plus B, vector A plus vector B, is represented in magnitude and direction. It is represented in magnitude and direction by the diagonal of the parallelogram. By the diagonal of the parallelogram. Okay, through their common point. Through their common point. This is known as the parallelogram law. This is known as the parallelogram law of vector addition. Parallelogram law of vector addition. So I hope students have understood this. If we have two vectors A and B which represent the adjacent sides of a parallelogram in both their magnitudes as well as direction, then you can look at the figure. Vector A plus vector B is the diagonal. It is the diagonal of the parallelogram represented in magnitude as well as direction. This is the direction, guys, through the common point. What is the common point? O is the common point. In the figure, you can see that the common point is O. From O, you have vector A. From O, you have vector B also. And then you can see you have vector A plus B again from O. So all the three vectors are originating from O. Vector A, vector B, vector A plus B. So O is the common point. This is known as the parallelogram law of vector addition. So I hope that students have understood this and have no doubts. Okay. Now, guys, let's look at some of the properties of vector addition. So our heading is properties of vector addition. Let's look at the properties of vector addition. So property 1, okay, called the commutative property. So I can write property 1, commutative property. Now let us see what is commutative property of vector addition. So basically, if I have two vectors A and B, so for any two vectors, A bar and B bar, we have A bar plus B bar equal to B bar plus A bar. This is the commutative property. Whether you add vector A plus vector B or you add vector B plus vector A, they are the same. So I hope students are clear with the commutative property. Then guys, let's look at property 2, which is the associative property. So this is the associative property where we now have three vectors. So I can say for any three vectors, A, B and C, I can write vector A, or since NCERT is using bars, let me use bar only right now. For any three vectors A, B and C, I can write A bar plus B bar ka addition with C bar is equal to A bar ka addition with B bar plus C bar. It means if you associate vector B with A and then add with C, it will exactly be equal to adding B with C and then adding it with A. Okay, so this is property 2. So the vector addition is associative, it is commutative. Okay, let us we can now have a corollary here. Okay, so I can write a corollary to this, or I can write a note to this. You can write a note. Okay, for any vector A, we have A bar plus A vector plus the 0 vector is equal to 0 vector plus the A vector, which is equal to the vector itself. So guys, what can I say? I can say that the 0 vector denoted by 0 bar is the additive identity for the vector addition. It is the additive identity for the vector addition. So I hope students have understood this particular note. If I take up any vector A bar, then A bar plus the 0 vector is equal to 0 vector. So I can say vector A plus the 0 vector is equal to vector 0 plus the A vector, which is equal to the vector A itself. So basically the 0 vector is the additive identity. Okay, we have done the concept of additive identity and multiplicative identity in relations and functions lecture also. Students are requested to kindly recall my lectures on relations and functions, where we had done the concept of binary operations, additive and multiplicative identity. So if I apply that concept done in relations and functions to vectors, 0 vector is an additive identity for the vector addition. Okay, because any vector plus the 0 vector is equal to 0 vector plus that vector is equal to the vector itself. So I hope students have understood this. And guys, this is where I intend to stop in this lecture. Now in the next lecture, we will talk about multiplication of a vector by a scalar. So I hope all students have enjoyed this lecture. Any doubt, you can unmute your mic and ask, or you can call up or mail me your doubts at divineschooloфeconomics@gmail.com. So this is where I